Hi everyone, it's Jakub from Capturing Reality. In this video, I want to talk about some recommendations for taking photos for reality capture. Just a disclaimer, this video is not a substitute for proper training from reality capture expert users that you can find in the photogrammetry community. I just want to talk about the very basics, and this video is intended for absolute beginners who don't know where to start. And over time, with experience and with experimenting, every user develops their own habits and workflows which work best for them and their projects. First, I will start with some basic recommendations. I will show you some schemes and give you some comments about them, and I will also show you some examples. The first recommendation is that do not limit image counts. Even if you think you finished your project and have enough images, shoot some more. Even if you use the VPI license and you pay for the number of images and the megapixels, in the end, you don't have to use all of them. The reason why I'm saying this is because it is not always possible to reshoot the missing parts, if there are any in your project. And this applies especially to outdoor scans. The environment can drastically change because of weather, lighting, some objects can be moved or even can be damaged. A lot of things can happen. So shoot more photos than you think you need, and in the end, you don't have to use them all. Another recommendation is to use the highest possible resolution you have at your disposal. But let me shed some light on this topic. For example, if you have a 24 megapixel camera, the file sizes in RAW format are not that big, so do not shoot 6 megapixel JPEGs with your camera. Reality Capture can process images that have 100 megapixels and even more. But that doesn't mean that you need such a camera to get good results. These types of cameras are usually attached on drones or even airplanes to cover large areas from great altitudes and still have a good enough resolution for the final result. For small-scale photogrammetry, even a 12 megapixel camera with sharp lens can get you the desired result. Speaking of resolution, we have a nice feature in Reality Capture that can help you estimate the final resolution of your model based on your camera parameters, or you can calculate how far from the object you should be to achieve the resolution you want. You can find this tool in the help section of Reality Capture when you search for how to take photographs. Next, we have do not lose focus. Reality Capture needs the photos to be properly exposed, in focus, without any motion blur and with minimum amount of noise. You need to adjust your camera settings accordingly to achieve this, and the settings can be different from situation to situation. Of course, you can shoot in automatic mode, but if you want more control over this, shoot in manual mode. You need to find a balance between the ISO, the shutter speed, and the aperture. Higher ISO will brighten the image, but will introduce more noise. Faster shutter speed will eliminate motion blur, but it darkens the image. Smaller aperture, that means a higher f-stop number, will increase the depth of field, which means more parts of the object will be in focus, but it also darkens the image. Also, you can help yourself with other equipment like tripods, monopods, and lights. If you never heard of terms like ISO, shutter speed, and aperture, I highly recommend you to learn the basic photography concepts. After you have the images, I recommend checking the focus of your images and remove the blurry ones and reshoot them if it is possible. In this case, the focus point was fine, but the blurriness is caused by the motion of the camera. Next, Reality Capture can reconstruct only the points that are visible on at least 2 images. The more images you have, the better. Here is an example of what I mean. In the top view, you can see that this point on the object is visible in images taken from these 2 camera positions. And like I said, more images, the better. So another photo was added taken from a different height that you can see in this side view. When it comes to the camera positions and the distribution of the images, there are also several recommendations that could help you get the best model possible. And one of them is shoot a full loop around the object and also loops from several elevations. You also need to keep track of what part of the object you already photographed, and the best way to keep track is to start at one point, move around the object incrementally, and shoot a full loop around the object and finish where you started. And like I said, make several loops in different elevations. Do not change the viewpoint more than 30 degrees. The smaller the angle among the neighboring cameras, the better, so you can move around the object even in smaller increments. Of course, the complexity of the scan object can play a role in this. Follow the shape of the object. Follow the shape of the object and also try to keep approximately the same distance from the object surface. This is important to maintain the same level of detail. You do not want one part of the model to be super detailed and the other very coarse. Or maybe you do. It always depends what you want to achieve. Of course, you can use some support loops that are a little bit further away from the object for helping the alignment, and you can disable them for meshing and texturing later in RealityCapture. In the end, I will show you an example of this. Maintain high overlap between images. The overlap between neighboring images should be at least 60%. Here you can see that these two cameras can see the same area in this overlap. And this is from the top view, and this is from the front view. Here are some real-life examples. In the red box, you can see the common space projected among these three images. And notice the motion of the window. It is visible on all three images, but it is slowly moving from right to left. Here is another example, but this time the drone was flying upwards, and you can see that in this case the overlap is very high. And there were some trees right next to the drone, so I was flying very carefully. Do not shoot panoramic pictures. Now, before jumping to conclusions, let me explain. In this example, let's say you want to scan this wall. Maybe you want to create some textures or something like that. If you shoot all images from exactly the same place, this is good if you want to stitch all photos to a panorama, but it does not contribute to a 3D model creation. What you can do is move slightly to another place and make another set of photos. But do not move too far from the original place. The photos will align. RealityCapture at this moment doesn't support stitch panoramas, but you can use the individual photos. However, we recommend to not use just this method alone, but combine it with the previous recommendations. And if you follow all of these recommendations, your camera poses will look something like this. The camera poses created a sphere all around the entire object. Some might say that this is overkill for a simple rock, but this is just for a demonstration. Avoid object movement. When you are taking images, be careful to not bump into your object. Also, when you are shooting outside, be careful in windy days because the relative position of the parts of your object needs to stay the same. This applies especially when you are shooting soft or light objects. But in some good conditions, some of our clients were able to reconstruct even bare trees. Avoid transparent and shiny objects if possible. This is the main disadvantage when you create a 3D model using photogrammetry. However, there are some tips and tricks how to shoot also shiny objects. For example, you can shoot two sets of photographs, one with the shiny surface for creating the texture, and one with the surface coated with a spray for alignment and reconstruction. In such case, you need to bear in mind that the reflections from the environment will be baked in the texture. And here is an example of this. This small shiny statue was first photographed without the coating, and after that with the coating. The images were aligned together because RealityCapture was able to find enough similar features in the images. And the images with the uncoated object were disabled for meshing, but some were enabled for texturing. And images with the coating were used for meshing, and they were disabled for texturing. Here is another example. If you scan some kind of glass and transparent object, you don't need the texture because the material itself can be generated in the 3D software, for example. You can use only one set of photos with the coating. In this case, there was a coating spray applied to the surface and also some black paint spots so RealityCapture can find the features on this object. Before I continue, I want to also mention polarizing filters and cross-polarization, which can also help, but it is not a solution for everything, pure metal for example. I will not go into detail, but this is not a topic for beginners, but I did a quick search before I recorded this video, and I found good practical resources about it, even for photogrammetry uses. The next recommendation is to avoid featureless textures. A featureless texture can be a flat single color material like the coated ball in one of the previous slides. And in this case, RealityCapture has a problem to detect common features between the images. There are some tricks how to shoot such surfaces, again with two sets of images, one with placed markers or some added texture to help the software align the images together, and one set used for texturing. But you can also use this in your advantage. If you have a constant featureless background, for example black, you can scan objects from all sides. And RealityCapture will detect features only on the object, like in this case, this orange. In this another example, the seashell was on a white background. RealityCapture was able to align all the photos and reconstruct the model nicely. Even though the camera was static on a tripod, the background was also static, and only the seashell was rotated manually on the white background. Or you can even help yourself with a turntable. Next, we have keep constant lighting conditions. Moving shadows, like from a flash, for example, can be to some extent filtered by the software during the texture blending. However, large shadows or dark parts of the object can cause gaps in the model and prevent correct alignment. And that will be all of the basic recommendations. And now I will show you some examples. Here is an example of a building. The camera poses are following the shape of the object, and in this case it was a combination of photos from the ground and photos from a drone. These outer loops were used for helping the alignment, and the more close-up shots were used for meshing and texturing to maintain the constant level of detail. It is not perfect. The main obstacles here were large trees overhanging the building, but the final result came out nicely in the end. Next is the tip on how to take photos for interiors. So shoot the opposite wall and combine it with the previous recommendations. Here is an example. This is a combination of laser scanning for the meshing and photogrammetry for texturing, so there was not as many photos as usual. In this project, the photos were actually automatically aligned to uncolored terrestrial laser scan point cloud without any control points. I talk about this more in a webinar we did with ZNF. The recording of this webinar is on our YouTube channel, and the link is in the description, so if you are interested, go and check it out. Here is another angle of the same object. You can even notice that some drone shots here were used to project the texture on the ground. Of course, you can seamlessly combine interiors and exteriors without control points if you follow these recommendations. We have a tutorial about this topic on our YouTube channel, so you can watch it. I will make sure that there's a link in the description. The next example is a pure drone mapping project. In this case, a flight planning application was used to generate the flight plan. In this flight application, you can use it to define the area you want to map. You can set the altitude, thus also the resolution, or in other terms, the ground sampling distance. Also, you can adjust the speed of the flight, which is very important in relation to the camera settings to avoid motion blur. Usually the application does this for you, but in some cases you might need to step in and adjust the speed and the camera settings manually to get properly exposed photos without motion blur. This is the same flight, but just in another view. In this case, the flight plan was generated in a way so the drone would approximately follow the terrain to preserve the ground sampling distance. And finally, I also want to mention that you can use masks in RealityCapture. Masks can be very useful for scanning small objects from all sides without the need of special equipment. We also have a tutorial about this topic on our YouTube channel, and there will be also a link in the description. Well, that will be all for today's video. If you have any questions, feel free to ask in the comments. If you have any hardware, camera and lens related questions, the best place to ask will be the multiple photogrammetry user groups on the internet. We can't test everything, and the users in the community use various cameras, lenses, and use different hardware configurations. You can also join our Facebook group Capturing Reality Arena and follow us on other social media. Also, if you have some future tutorial suggestions, please write them in the comments. And thank you for using RealityCapture.